I'm Chris Anderson at the EEWeb Tech Lab. Today I have the KMX61G demo board from Kionix, the industry's first highly accurate gyro emulator. In general, gyros are used to measure an object's angular velocity, which allows you to determine its orientation. MEMS gyros have become very common in smartphones, gaming devices, and wearable electronics, but they consume a lot of power, typically on the order of 5 or more milliamps at 3.3 or even 5 volts. For battery-powered devices, that's pretty significant. Additionally, they're usually paired with an accelerometer and a magnetometer or e-compass to allow the MCU to stabilize the data over time. The KMX61G is a 6-axis sensor integrating a 3D accelerometer, 3D magnetometer, and an ASIC that provides a FIFO data buffer and motion-driven interrupts to the sensor hub or application processor. Kionix also provides the sensor fusion software that combines the mag and accelerometer data to output the emulated gyro data, as well as algorithms for magnetometer auto-calibration and magnetic interference rejection. This in effect gives you 9 axes of data from a single sensor IC and consumes about 1/10 the power of a traditional gyro and occupies less board space, making it ideal for space and power sensitive applications such as smartphones, laptops, gaming devices, and wearable electronics. The concept of taking data from two sensors to emulate another is not new, but the advantage of the KMX61G is its low operating power, drawing only 450 microamps in operation and 1 microamp in standby, and the performance of the software they provide for the sensor fusion and other functions. That software running on either your sensor hub or application processor should draw less than 500 microamps, making for a total 9-axis solution drawing under 1 milliamp. On the demo board, there are 2 sets of sensors. One is the KMX61G, the other is a gyro paired with a mag and accelerometer. In the demo software, there are 2 cubes that display on the left the traditional gyro data and on the right the emulated gyro data. And as you can see, as I move the demo board around, they track fairly closely. It doesn't track perfectly, but it really doesn't need to, because if I'm playing, for example, a game on my smartphone, a racing game, and I'm trying to turn my car, all I know as a user is that if I'm turning my device and my car's not turning far enough, then I need to turn my device farther. So the real difference is I can play longer because the KMX61G consumes much less power. Nothing comes for free, of course. This type of sensor can be thrown off by things like centripetal force, reducing the confidence of the data. This could be a problem in defense applications where the absolute accuracy is critical, or something with very high rates of full range motion, such as tracking a baseball for a TV broadcast. However, the applications I mentioned previously, wearable electronics, laptops, mobile devices, gaming devices, etc., typically have more limited motion and constitute a very broad market. The KMX61G provides designers with a highly accurate gyro alternative that draws much less power and occupies less space than a traditional gyro.